بسم الله والحمد لله والصلاة والسلام على رسول الله. الإخوة والأخوات، الزملاء والزميلات، أطباء المختبرات الطبية، من يحضرون معنا هذه الدورة، سلام من الله مبارك طيب عليكم ورحمته تعالى وبركاته. يسرني أن أعود في حلقة اليوم إليكم في الموضوع الذي بدأناه وتدارسنا بعض الحلقات فيه، وهو ضبط الجودة في المختبرات الطبية laboratories. And in the last session we have discussed together the quality or the quality control of the quantitative laboratory procedures, and we set some guidance and some specific procedures and steps that we need to adopt in the laboratory so as to set the program, and also we pointed out the necessity and the importance of the program specific for quality control and how to implement those steps in the laboratories. And also we pointed out the importance of adopting or implementing and utilization of the tools which had been set specifically for that issue. We went through some mathematical procedures and statistical procedures which are indispensable for setting the programs and implementing that program concerning the quality control of quantitative laboratory services. Today we resume and continue in the same direction, and we want to point out that when you are applying the statistical and scientific and mathematical procedures in the laboratories, some symbols are very necessary to understand because we need to encounter from time to time. So it's very necessary to understand them from the beginning and to know what they stand for. This sign is for summation. It stands for the values that have been added up. It is the action of adding up and summing the values. N, it stands for the number of data points. How many data points have you carried out? How many examinations you have done in the laboratory to obtain those values. X1, X2, X3 up to Xn are the measurements. All of the measurements that you have carried out in the laboratory start from 1 through N. From 1 through N. X bar represents the mean. The mean, that value which you have calculated, which stands for the true value that we are adopting in the laboratory, which is very necessary as an indicator to follow the examination of the situations. To calculate the mean, as we said before, it is an action of summing the values that you have collected and subtracting them on the number of the measurements that you have carried out, or the points of measurements that you have carried out. That is the mean. X bar stands for mean. The first measurement is X1, the second measurement X2 through Xn, the last value and the last measurement that you have carried out in the laboratory to obtain the values that you come to utilize to develop and to design the quality tool, the quality chart that you are going to adopt. I would like to point out that it is the same procedure carried out by the manufacturers of automated equipment that you are using in the laboratory, the clever equipment that you use to calculate, to carry out all those calculations by itself and present you in front of you the ready calculated results. It is the same story that take place inside the equipment. To calculate the ELISA values, which is a bit different from those achieved in the chemical laboratories, you need to run the control 20 times, as we said before, 20 times through 30 days. Then you record both optical density, the optical density of the values, and the coefficient of variation of the value, the cutoff of the value. The cutoff is very familiar to those who are performing ELISAs. Cutoff of the values. So you obtain and you counter those both. Then you divide the optical density by the cutoff and obtain a ratio for each value that you have achieved, for each value of the 20 values. So you do have 20 ratios which represent the optical density over the cutoff value. And then you need to, this is carried out to standardize. This ratio is obtained so as to standardize those values, to standardize the data that you have obtained through those values. Then you add the different ratios, the old ratios together, to sum them, then divide them by the number of measurements so as to obtain the mean by the same procedure, or like the same procedure which you have carried out before. It is just a step of standardizing the data and the values that you have obtained through the ELISA procedures. This is at least an example of the values that you have obtained through measuring or testing the 20 samples and obtaining the 20 values. Going through this, you can notice that some values, which is 196, have been repeatedly noticed. I think 4 days, which is the predominant value that you encounter in this list of values. One odd and unique value is observed, which is 270, which is highly above those values that you have obtained. When you encounter this value, which is named outlier, because it is extremely far from the other values, you either continue to calculate the mean using that value, including that value together with the other values, or you can just ignore it, and nothing will happen. I would like, in my point of view, I prefer to ignore such odd value. It stands for the failure of the system at the time when you are measuring the control materials at the time that you have you obtain that value. But this failure didn't continue. This is indicated by that the values which come after that value are uniform, and this mistake didn't continue. So it is better to ignore that value and include the other values. You sum them and calculate the mean. Normal distribution is the phenomenon that is observed, and actually we need to notice it so as to assure the quality and the capability of and the effectiveness of the measurement system that you are adopting in the laboratory. All values through the normal distribution, all values symmetrically distributed around the mean, as is noticed in this shape, and they form characteristic bell-shaped curve. Bell shape. This shape looks like the bell. This one is assumed quality control statistic all over the world and adopted, and it is a phenomena and feature of a suitable and adopted analytical system ever adopted in the laboratories. So if you obtain any shape other than this one, you need to analyze and to assess your procedures, and for sure you'll find a defect or weakness somewhere. A quality control is used to monitor the accuracy and precision of the assays. This is in the quantitative measurements in the laboratory. The quality control procedures in the quantitative services is performed to achieve and control both accuracy and precision. But what is accuracy and what is precision? These terms should be understood very clearly, because these will be the measurements and the indications of the quality of your system to notice every time and then, and they are the basics that guides you to assess from time to time your system and to test it. Accuracy is the closeness of measurement to the true value. Closeness of those measurements to the true value. Although it is sometimes difficult to specify and to define the true value exactly, but you can assume where the true value logically might lie. Anyhow, accuracy is the closeness of the values that you have obtained through examining the quality control materials to the true value assumed to be available in the sample that you are examining or in the control material. Precision is the amount of variation in the measurement or the refutability of some values, as we preceded before, of the measurement within the values that you have obtained. Bias is the difference between the expectation of the test results and an accepted reference values. Accepted reference values that are known and adopted by all people, those are in the laboratory, in a specific laboratory. The variation and difference between it and the expected and the expectation of the test, or the values that you expect to obtain through examining those materials. Accuracy and precision. This slide has been designed to indicate and to point out and to clarify and illustrate the difference between accuracy and precision as indication of the reliability and effectiveness of the system that you are adopting in the laboratory. You find in the shape of those circles, two circles within each other, the central circle indicates that there is one midpoint in the center of the central circle, which represent the true value, and then the measurements which have been carried out through examining, which have been achieved through examining control materials, lie on the center of the central circle, quite close to each other. Closeness of those values to each other indicates precision, and also the closeness of all those values to the central point, which is the target value, indicates accuracy. So this shape indicates both accuracy and precision. It is the phenomenon accepted and that we are looking for to indicate the quality and the effectiveness of the system that is adopted in the laboratory. In the middle shape, again, the values are close enough to each other. Closeness of those values to each other indicates precision. Actually, they indicates precision. But all those values are quite far from the central value, from the central point, which indicates the true value. So all the values are far from the true value. This situation indicates lack of accuracy. So the system achieves precision but missed the accuracy. So it is an unaccepted procedure, unaccepted system, because the accepted system should achieve both accuracy and precision, and it should lack the bias. The shape number 3. In this shape, all the values are quite far from each other, and at the same time quite far from the true value, which is assumed to be here in the center of the inner circle. So, being far from each other, they lack precision, and being far from the central value, which is the true value, indicates inaccuracy. So in this shape, no accuracy and no precision, and it indicates very big failure, and also pointed out that this system is unsuitable for use in analyzing the patient samples or adoption in the laboratory. A standard deviation and probability for a set of data with a normal distribution, random measurement will fall within any random measurement within the values that you have obtained by examining repeatedly the control material. Any random measurement value will fall within plus or minus 1 standard deviation to the ratio of 6 to 8.3%. It means that 68.3% of the value of the whole value fall within plus or minus 1 standard deviation. And 95.9% of the values fall within a range of plus or minus 2 standard deviation of the times. And 99.7% of the values that you obtain fall within the range of plus or minus 3 standard deviation. That is the normal distribution which we have discussed before in the previous slide. Normal distribution. It is estimated by that the and it is an indication of the effectiveness of the system. If these values are quite different from this order, you need also to assess and to analyze your system to see what is the cause of the weakness, what is the cause of an abnormal feature indicated by those central tendency phenomena. A standard deviation. As we said before, standard deviation is the principal measure of variability used in the laboratory. In the laboratories which are adopting such services of quantitative measurements, principal measurement. Being principal measurement is very necessary to achieve and to utilize in the laboratory to control the services that you are providing to your clients. And to calculate the standard deviation, you need to sum, as we said before, to obtain you need to obtain the mean and to multiply the mean by the power, to raise it by to the power. To use that model of an equation to sum all the differences between the mean and every unique value you have obtained by examining the control materials, and that sum of ratios and variation is raised to the power 2 and divided to the number of measurements minus 1. This is how standard deviation can be calculated. The other measurement also, which is necessary to use in the laboratory, is the coefficient of variation, CV. Coefficient of variation is actually the ratio of the percentage of standard deviation to the mean. It is just calculated by dividing the standard deviation by the mean and multiplying it by 100 to obtain the percentage. It's very simply developed. Coefficient of variation is used to monitor precision. If it is narrow, very narrow, and achieving very minor value, it means that the system is very competent and it is precise. Coefficient of variation is used also to compare methods. Those methods achieving or maintaining little volume or small value or small percentage are preferred over those achieving or maintaining higher or bigger values. Coefficient of variation ideally should not exceed 5%. They should be less than 5%. uh, Levey-Jennings chart as a model of control graphs or control charts ever used in the laboratories to monitor and control the quality of quantitative examinations. So Levey-Jennings chart is graphically representing control range. Control range. To develop the chart, you need some requirements which are very simple: pencils and rubbers and ruler and arithmetical paper. Arithmetical paper for the simplicity of plotting the values that you obtain by examining the control materials repeatedly. Statistics for quality control. First of all, you need to assess control material at least 20 times, as we said before, and update the 20 data throughout 20 to 30 days. Then you have to ensure that the procedural variation is represented. This is to say, if you have different technologies in the laboratories used to test or to examine the samples, you need to include those different technologies within examining or testing the quality control materials to obtain those values with which you are going to design your control chart. For example, if you have 2 or 3 equipment used together in the laboratories, you need to examine either to examine all the samples, all the 20 samples, 3 times every time within one specific equipment, or to include or to examine some of those values in equipment 1 and the others in equipment 2 and the others in equipment 3, and then you merge the values and count them together, sum them to count the mean. So you include them in developing that chart. In this way, the different technologies and procedural variation is considered within your chart. It means that the chart which you develop in this procedure will be representative to all the technologies that you are using in the laboratory. Then you calculate the mean, and then the plus or minus 1 standard deviation, and plus or minus 3 standard deviation. Then you draw lines according to the values that you have obtained. The mean is the first value, and you need to place it in the center of the page of the paper, representing the true value, the central value, which is the true value. So the mean represents the target value. Then you add one value of standard deviation to the mean, so you will obtain this level, this line above the mean, which is plus 1 standard deviation, and in step 3 you subtract that value of standard deviation from the mean, then you obtain plus 1 standard deviation. Then in the third or fourth time you add double standard deviation to the mean, then you obtain that value which is plus 2 standard deviation, and then you obtain minus 3 standard deviation, 2 standard deviation, and then plus 3 standard deviation, and finally minus 3 standard deviation. So this is the range of the measurements that you need to adopt in the laboratory, or you may be satisfied only within plus or minus 2 standard deviation, and this will be the range of your measurements. If you adopt this, then you will never accept any values above or below those levels. By using this chart, every time, for example, if you use to examine the control material once a day, you need to develop this chart like this, as we said before. Then on day 1, the value that you obtained by examining the control materials lies here. For example, it is exceeding the central value, which is the mean, by 1 standard deviation. So it lies here on the line of plus 1 standard deviation. Next day or day 2, you obtain that value which lies here, which is outside minus 2 standard deviation, quite near to minus 3 standard deviation. If your laboratory accepts only plus or minus 2 standard deviations, then this value will be considered out of control. Out of control. On day 3, the value lies quite near to the mean, which is highly accurate. As we said before, accuracy is the closeness of the values to the true value, and we said the mean represents the true value. So on base of accuracy, this value is the most accurate than this one and than this one. Then you continue to plot every day the values that you obtain by examining the control materials in the chart, and then you may come to notice the point that is occupied by every specific point, every unique point, and also to notice and observe the relationship and variation and distance between the all points or subsequent points, so as to set or to evaluate the overall system that you are adopting in the laboratory. Number of controls that you use in the laboratory to set a system for quality control of quantitative procedures. Interpretation of the values depends on the number of controls run with the patient sample. If you use one control, it is good, but it is not good not to use any control. So still it is accepted to use one control material with the patient samples, and in this case you need to accept the results if the control value is within plus or minus 2 standard deviation, unless there is a phenomena of shift or trend observed. Otherwise, these values are accepted in your system if you are using one control material. But it is better to use more than one material, quality control materials. If you use 2 levels of controls, then you need to apply Westgard multi-rule system. And we will come later to discuss this in detail. Using control program to detect the errors, you need first to identify the types of errors. The first type is random errors, and in this case variations in QC results with no pattern. It is only a cause of rejection if those values lie outside 2 standard deviations, as we said before. So the random error is somewhat accepted unless it lies outside 2 standard deviations, either plus or minus. In this case, these values are not accepted and the run is not accepted. The case should be discussed and investigated. Then the problem will be pointed out and the source of the problem will be identified and known. Then you solve the situation and repeat or resume analysis of the samples to issue reports free from defects or free from weakness and errors. The other type of errors is systematic error. The systematic errors are not acceptable totally in the laboratory. You need to identify them and to study them and know the sources and causes of those problems. You correct that situation of the source, and then you repeat examination of the samples. Examples of systematic errors are shift. Shift means that the control values lie on one side of the mean 6 consecutive times, either above the mean or below the mean, even if they are still within the acceptable limit, but they are not accepted by being consecutively on one side of the mean. They indicate an abnormal distribution. The normal distribution is the distribution of the values around the mean, indicated by the central tendency before, as we discussed that matter. but not being on one side of the mean, either above or below the mean. If this is repeated 3 times or 6 times or more, then the system should discontinue. You need to stop using that system. You investigate, you and understand the cause and the source of those. It's a weakness actually of that weakness and error. You solve the situation, and after that you come back to retest the samples. The other example of systematic error is trend. And trend is indicated by the control values moving towards one direction, either going upward or downward, and it doesn't matter from what point they will start. But in this situation they use to be described as heading outside or towards an out of control value. If system is not stopped, or if situations are not resolved, then finally they will go out of control of the values, but they used to go on one direction, heading to outside of the control. This is also a systematic error which should discontinue. The situation should be analyzed and investigated, problems understood, resolved, and after that you come back to reassess or to examine the patient samples together with the control materials again. This is an example of shift. Multiple values, consecutive values lying on one direction above the mean, and this also, as we said before, should discontinue. And this is an example of trend, systematic error. All values going upward, heading to the out of control. If it discontinues, then they will go completely outside the chart itself. So this system should be stopped and observed and noticed, and then after resolving the situation, measures will be resumed and utilization of the system should be done. Measurement of uncertainty. Uncertainty represents a range of values in which the true value is reasonably expected to lie. And this is because it is not necessary in clinical laboratories to identify exactly one unique specific value as the true value. Although it is difficult to count this, it is also of no use. It is of no use. Still, I can indicate the normality of the values within a range. So I will just calculate or understand or point out a range within which the true value is expected to lie. So this process is satisfactory in health laboratory to set the quality. Measurement of uncertainty is estimated at 95% of coverage, as we said before, because 95% of the values obtained by consecutive and repeated examination of the control materials covered 95.5% of the values. So by using and taking consideration the central tendency, for sure the true value will lie in one point within that value, within that range, and that's necessary. So any value obtained by testing the control lying within that range is accepted, because the target value is expected to lie also within that range as indicated statistically before. The more precise the method that you are using in the laboratory, the smaller the range of values that will fall within 95% of the 95% of the total number of values. This is because the variation will be very narrow between different values, and even a lot of many values will come repeatedly, will repeat themselves. So in this case the range will be very narrow. For most instances, a range of plus or minus 2 standard deviation is accepted as measurement of uncertainty. Measurement of uncertainty. Although uncertain, but this phenomenon is highly accepted in the laboratories, and no need for looking for one specific unit value, which is the true value. Uncertainty that is explained by random variation. It is just due to the random variation that we discussed before, and that is adopted by every analyst in health laboratories. This necessitates the acceptance of a range, specifically and scientifically and statistically calculated, and logically the true value is assumed to lie in one point, mostly in the center of that range, as we indicated by the bell shape. If QC, quality control, is out of control, if the values that you obtained by examining the quality control materials lie outside the control point, what will happen? Number one, immediately stop using that system. Stop testing. After you stop the testing, then identify and correct the problem. Identification of the problem actually necessitates many operations and procedures that used to take place, and you need to investigate actually professionally to identify the problem and to set the procedures of correcting that problem, and it is very necessary to depend and rely upon the policies that have been previously developed for that laboratory, as we said before, because that policy should include different corrective actions of different problems. Then after that, after you understand the problem and resolve it, then repeat testing of patient samples and controls together after correction. Do not report patient results until problems are solved, because this action is of no use. It is of no use to use a system, a defective system is still experiencing problems, unless you resolve the problem and assure that your system has become effective and without errors. Never use it. And after that, make sure that the system and find the indications and prove that system have come back and became effective and indicates good and proper performance. And this should be by evidence-based and practically seen by your observed by your system of evaluation and assessment. To solve out of control problems, first of all, as we said, identify the problem. And to identify the problem, sometimes you may need to verify in very clever and close observation. To point out the problems. Then, to do this, to find, after you identify the problem, so as to set the procedures and the corrective actions, you need to refer to the established policies, as those policies include the corrective actions to be adopted in the facility or in the laboratory, established policies and procedures for remedial actions. And this is also a standardized method to adopt in the laboratories, because no individual person in the laboratory should have his own procedures of resolving the laboratories, and no one should have its technicalities and protocol of identifying the problems. All the processes should be standardized and adopted by everybody in the laboratory by the same manner and the same way. In this case, all the outcomes and results will be the same in the laboratories, and the specific problem will be handled specifically and specifically and scientifically and systematically by everybody who is working in the laboratory. Possible problems frequently encountered in laboratory services is the degradation of reagents of the reagents and kits used in the laboratory, and control material also degradation and spoilage, and the operator errors, which are very common, actually, which may indicate poor training or poor qualification, or poor concentration of the people working in the laboratory, and failure to follow manufacturer's instructions without reviewing the manuals, and without reviewing or reading instructions, and people working in the laboratory may fail to understand the language which is used by the manufacturers. This is why we stated before the technicalities and procedures adopted in the laboratory should consider the language of the technology that is used, and never use any equipment or any system in the laboratory using a language which is quite difficult to be understood by those working in the laboratory. One of the causes and the phenomena of the mistakes and errors taking place in the laboratories is an outdated procedure manual. The procedure manual should be kept updated, and whenever you change material and the tools and the resources that you are using in the laboratory, you will need to update your procedure manual. If you use different lots or different reagents or different equipment, you need to develop or to update your procedure so as to meet the new situations, but never use an outdated or any procedure manual which is unrepresentative to the technology and the procedures and the resources that you are using in the laboratory. One of the causes of the errors in the laboratory is the equipment failure. Equipment in the laboratory actually should be well managed and controlled and observed from time to time. Close observation is very necessary for the different technologies that you are using in the laboratory, for the sake of getting the maximum use of those technologies and preventing them from going or from falling outside of control. Failure of equipment and technologies in the laboratory indicates lack of system of equipment or technology management. If there is any sort of equipment management failure or prompt failure or accidental failure will never take place in the laboratory, so it is very necessary to well manage the technologies used in the laboratory so as to achieve quality of the services that you are using. A calibration error also is very important tool and very important cause of problems and errors that take place in the laboratory, and it indicates either people are not or are misusing the information that are obtained by calibration, but the calibration processes themselves are correct. Otherwise, sometimes the calibration processes themselves are incorrect. If they are incorrect, then they yield false values and false results. If you people adopt and implement those results, then errors will take place. Or in sometimes no calibration used to take place in general, and if you don't calibrate your system, your reagents, your analytical system in general, then you wait for major problems to take place in your laboratory. To summarize, I would like to say a quality control program of quantitative tests is essential. It is very essential actually to control the quality control or quantitative laboratory examinations, and it should be monitored. It should monitor all quantitative tests. Never expect some quantitative process in the laboratory as inessential. No, you need to target all the procedures of wielding quantitative examinations in the laboratory by your system of quality control in the laboratory, and it should have written policies and procedures before starting to apply the procedure. You need to develop the policies and after that to develop and establish standard procedures out of that policy, and then create another steps to fulfill the system and the program of quality control. And these policies and procedures should be followed by laboratory staff exactly and closely, and no one is allowed to bypass or to ignore or to work without using those, or considering and adopting and applying and obeying the policies and applying the procedures which have been adopted and endorsed. It should have a quality manager in the laboratory with the system. There should be a quality manager responsible for monitoring and reviewing and assessing QC data. There should be abundant QC data and records increasing day by day, because any activity carried out in the laboratory by the laboratory staff on the area of quality control should be actually should be reported, and it should be registered, and those records and registry are to be evaluated from time to time by a specific or a well-assigned person who should be trained specifically and effectively on that function. The system should use statistical analysis and provide for good records. Statistical analysis, as we discussed before and as you have seen, it is very necessary, and without those statistical procedures the system will not be on place. And to fulfill and to maintain and to point out and indicate the effectiveness of that system, all records should be well managed. All the records should be well managed and made ready for the review of those responsible people, either managers or technical or consultants, who use to evaluate the overall system of the health of the healthcare facilities, including the laboratories for sure. It should provide for the troubleshooting and corrective actions. Troubleshooting actually is the expected or repeatedly expected problems which used to arise from time to time, and due to the importance of the troubleshooting, the manufacturers of the kits or of the equipment or any components of the system adopted in the laboratory should point out and clarify and make aware the end users with the troubleshooting expected to take place, and providing them by the procedure which they should adopt and carry out to overcome and resolve those problems. Having effective quality control system in place will overcome and will make possible dealing and handling and managing the problems of troubleshooting of the system. Key message that to be aroused and sent to our clients and to the attendees is that accuracy program allows the laboratory to differentiate between normal variation and errors. Errors are always there in the laboratory. I need to point out this truth. Always errors are there, because laboratory profession is a complicated one, and when the profession is complicated and difficult, always it is associated with problems and mistakes and errors. So errors are always there, but we don't see them because we don't look for them. Adopting an effective quality control program means that you are looking for the problems. Otherwise, you are accepting to provide service to your clients which are incorrect. You agree to work with unscientifically and unprofessionally if you are not adopting any kind or any type of quality control program. So as to detect and resolve those errors, you need to adopt a quality control program effectively designed and endorsed and assessed. The QC program monitors the accuracy and precision of the laboratory assays in what's known by quantitative laboratory services. The results of patient testing should never be released if quality control results of the test run do not meet the laboratory target values. When the control values lie outside the target value, outside the accepted range of quality, no issue of results should take place. I would like to remind you that this material has been drawn from ISO 1589, which is adopted by the Federal Ministry of Health in Sudan as a Sudan National Quality Control management system, and that system actually is comprised of 12 essential building blocks, including process control, which include quality control procedures in health laboratories. Some questions have been included to assure the effective attendance of those who have registered and joined us in this presentation, and I'm expecting answers from all people. The correctness of answering indicates the usefulness of the training course and the effective attendance of those attendees. Calibrators have the following characteristics or functions. Calibrators contain a known amount of analyte being tested. Calibrators monitor the quality of reagents. Calibrators monitor the quality of the sample, and calibrators prevent equipment failure. Which one is the most correct answer? Point out the most correct answer. Question 2. The reproducibility of the value of a value upon repeated measurements is referred to as accuracy, precision, bias, and errors. Which answer is more correct? The probability that a given control value will fall within plus or minus 2 standard deviation of the established means or established mean is 68.2%, 99.7%, 95.5%, 92.5%. Thank you very much for the attendance, and see you.